Welcome to today's webinar. Today we will show you top features for reinforced concrete design and why these features make switching to RFEM 6 worthwhile if you are still working with RFEM 5. My name is Andreas Hörold. I'm responsible for marketing and public relations in the company Dlubal Software. For instance, the German and English webinars, technical content of the website, newsletters, and so on. I will be the moderator today and I will answer your questions together with Richard Hase. The presentation will be done by Alexander Meyerhofer. He's the head of product engineering concrete and he works also in the customer support team. Richard Hase is also responsible for the concrete design add-ons, and he works also in the customer support team. Okay, I say some words how you can ask questions. At first, I switch off my webcam. If you have questions, just press the button with the question mark, then enter your question in that field, press send, and we will receive your question and we will answer you. The other way is to watch the entire webinar and then email your questions to info@dlubal.com. Okay, that's for the moment all from my side. I hand over to Alexander. Alexander, you can start.
Thank you, Andreas, for your introduction. I want to say also hello to today's webinar. Top features for the reinforced concrete design. And I want to show you the top features by the main following 6 topics. Firstly, want to show you the advantages due to the concept of the add-on, of the new concept. Then I will go to the general features in the reinforced concrete design, which are for member design and for surface design together. In the third step, I will go to the detailed feature highlights for the member design, then for the surface design, and one topic which I want to highlight is then also the deformation analysis. Then I will go to the new design checks in RFEM 6. In the 5th point, I will show you some possibilities for advanced analyze options to use the nonlinear material behavior of the concrete in the statically analyze and make a time-dependent analyze. And last but not least, I will give you an outlook and further developments to see what will be released in the next future and what topics are at the moment in progress. The advantages due to the add-on concept is that we have in RFEM 6 one add-on for the concrete design. And this add-on for the concrete design includes now all tasks which you need for the design of the reinforced structure. If we will compare it with our RFEM 5 solution, we have in RFEM 5 add-ons, single add-ons, and it was necessary that you make the design for the beam, for example, in the add-on RF concrete members, and the concrete and the column design in RF concrete columns, the slab and wall design in the surface, in the concrete surfaces. And if you want to make a punching design for the slab, you have to open again an additional add-on, which was named RF Punching Pro. And we see now in RFEM 6, we have everything in one add-on included. So there's no single add-ons which you have to use, and everything is included. Further, we have in the RFEM 6 the deflection design. The deflection design with the effective stiffness method, which maybe you know from RFEM 6 from the add-on RF Concrete Deflect, which you had to buy additionally to the add-on RF Concrete Surfaces. Here in RFEM 6 it's included. Also included are the standards. So all your Eurocode, ACI, Canadian standards, for example, are all included in our add-on package. In RFEM 5 you had to buy module extensions for each standard. So to consider it now, you buy one add-on for the concrete design and you have then the full package for your work. You can start directly in work and you don't think about what could be necessary to buy additionally for some design checks. Yeah, advantages in the program applications. The possibility which we have now implemented in RFEM 6 is that we can activate only the necessary add-ons for our design tasks. If we want to design only a concrete building, a reinforced concrete building, then we activate only the concrete design, for example. We don't have a big number of additional add-ons in our main program if we don't want it. We can really control it before we start with the work in the main program. We decide what we want to have and what we want to use. And also the design standards. You define only the design standard in one tab. When you start with your work, you go to the base data and then you make the input of your standard. If you came from RFEM 5, for example, you remember in each add-on you have to select the design standard. And also the automatic assignment of the design loads. What you want to use for the design of the member, of a surface, of a deflection, of a punching node. If you was in RFEM 5, you have to define in the table 1.1, the first table, if you remember, always the design loads. And this is here automatically done. I will show it in RFEM directly. I will go, for example, here into the base data, which I mentioned before. So here we have the selection of our add-ons, and you see the standard. I've defined the standard on the national annex for the concrete design. And if I have activated more add-ons, for example, steel and timber, I can activate it. I can choose also my design standards here. And you have all activated standards here in the list. This list is also in the protocol. It's very good documented that you see what standards are used for your design. And the same thing is for the used load combinations. What load combination will be used for the design? We have design situations, so we have ultimate limit state. We have for the serviceability, the quasi-permanent and frequent or characteristic design situation. And we see here for each design situation, you can select what design add-on should use the included load combination. If we go to the overview, we see, oh, here it's only one, but in the next one we have these load combinations, which are already then generated and will be then used in the concrete design automatically. If I do it when I defined my loads, it will be automatically assigned to the add-on for the design. Further, we had in our new concept of RFEM the use of some types. We avoid in the development that the user have to do some inputs more times. For example, if we have here our columns, these columns have an buckling length, and this buckling length is then defined one times. So if I go to the effective length, we have here one type which is assigned, for example, now to this member number 16. And if I take a look inside, we see the same settings for the buckling length for the column is assigned to many other columns. So it's not necessary to do it more times. This is a big advantage. Okay. Then the next topic is for the design in RFEM 6. I mentioned it in the first topics that the design of the surfaces and members is included in the add-on. It is not only included, it is done together. We will have then the combined, if we calculate it, we will have then the design of the member surfaces and punching notes together in one calculation. This is also the topic which is very good, that we use, for example, one material for each. We can use it for members and for surfaces. And for example, the creeping settings for concrete will be done now in the material properties. And if we consider creep or shrinkage, then we have here the conditions for it, the settings, and it will be calculated automatically for each cross section, for each surfaces. And it will be then used in the calculation. If you remember the way in RFEM 5, you have to define the creep and shrinkage parameters in RF concrete members or in RF concrete surfaces. And if you consider it in the stability design, then also in the RF concrete columns. So this is a big benefit. Further, in RFEM 6, we have a very good control of our design checks. Each design check will be controlled by some configurations. So, for example, for the ultimate limit state, we can get, we have every done design check available. We can activate it. We have then the settings for it, for punching, what will be done, how are the limit values. Every design can be controlled. You see here for members, for columns, for surfaces, and for punching, everything together on one place. And you can design it to more objects. You can change the settings and have different settings in one global structure. So you're totally free in the control of the designs. Then for the serviceability configurations, we have here one new thing which is very good. Firstly, we can activate each design check. And the feature which we have here, we can use, for example, for the crack width calculation, different design situation. So you see, normally the crack width calculation will be done for the quasi-permanent load for reinforced concrete structures. But now we can use it and define for each design situation my own value, my own limit value. This is completely new. This was not possible in RFEM 5. RFEM 5 you can say it was possible to say make the design check for frequent and characteristic. Yes, this was possible, but you was not able to define different design values. This is possible now for the stresses, for crack width, and what is also a big benefit if you have, for example, such a situation, and you will calculate then the required longitudinal reinforcement for the selected design checks according to the serviceability design. Then we will get also additional results, where the results are then splitted between the design situations. What we have here also new is in the inputs type for concrete, our durability classes. This is also a type which can be used very often. So these durability classes or exposure classes you define for your member, for your surfaces, and then you assign it to each member, to each surface which you want. And this durability class will be then used, for example, for the columns. And here you get automatically then the minimum concrete cover, which is necessary for the design. And the next benefit is that with this durability class, we calculate automatically the limit value for the crack width calculation. One topic which we don't see now is that our add-on calculation can use the multiple calculation cores, which are available on the computer. So this is a very good performance improvement. And this was also not possible in RFEM 5 for the design of the members or surfaces. So now we can go to our results. The results are very detailed, and you can take a look to every design checks. You have here a sort according to the design ratios for members, or the reinforcement for members, or design ratio for surfaces, or for the punching nodes. So if we go to the members, now you see the calculations have to be done new, because I changed the setting for the crack width calculations, and now we have to design the building again new. We make the crack width calculation. We calculate also the required reinforcement, like I said, for the crack widths and the stresses. This is also new, which was not possible in RFEM 5, to get the required reinforcement, for example, for the limitation of the maximum concrete stress in the serviceability state. So these are completely new functions which was implemented, and this will help the user also in his design work. Okay, so we see here we have every design check listed, what is done. Here for ultimate limit state we have many filters. If you want to see the serviceability checks, then we can activate it, and we see always the design ratio and what was designed. Further, we have in the design checks, for each design checks, all variables which was used in the calculation here in our tree, so we can control the calculation. And one highlight is also that we have here an info text. And this info text is completely shown and written like a hand calculation. So you can follow the design for each location. You will get then also the resistances, and you see how the calculation was done, and at the end you will see how the ratio was calculated and from where this ratio comes. Special topic, this info text can be also printed to our printout report. You can print it in a PDF or send it directly to a printer if you want to check it by hand. Is everything possible. Printout report, I printed it already to the printout report. This is also one new highlight in RFEM 6. Our printout report was completely new programmed. We have now, you see, it's very fast loaded. In RFEM 5, we had sometimes the problems that the generation of the printout reports takes a long time. So in RFEM 6, this is better. We can work on parallel windows. The printout report can be open, and you can work parallel in the RFEM 6 window and send here also some images and so on to the printout report. And you see here, this was the design check which I printed before to the printout report, and you can follow the completely calculation step by step. It's a very nice topic. Again, a nice feature for the calculation is that you see here in the navigator all results for surfaces, for members together. So it's not necessary to switch here between some design add-ons which you have to do in RFEM 5. If you want to go to results from members, you switch here in the main combo box for the results from members, and then you see only the results from members, or for surfaces, it doesn't matter. And here we are able to see the results together for the required reinforcement, for example. We can see then also the punching nodes if we want to activate it. At the moment we have here the design checks which we can see. This is the proof from the defined provided reinforcement. And you see here the safety factors and the ratios. And the other topic the other three is only the reinforcement. So you get here the required reinforcement or the provided reinforcement. And the not covered reinforcement. So the not covered reinforcement is then the difference between the required and the provided reinforcement. Is very helpful for the user if you will have too less reinforcement, then you see directly the required value which you have to add. About the results, if we go to the required reinforcement, we have here also a possibility to see the results for the as envelope for the whole design situations. This was the situation in RFEM 5. We saw always only an envelope. Of course, this is what we need. But if we want to see the results for different design situations, for example, what reinforcement is necessary for the limitation of the crack width. So I show only now the slab over the first floor. I go to the result navigator, and then I'm interested in what reinforcement is necessary for ultimate limit state. If you take a look here to this column, we see here about 7.5 or 8.5 square centimeters required. And if you want to see what is required for the crack width calculation for quasi-permanent load, we see here in this area there are the cracks, and we need here about 6.08. And if we go to the next design situation, because it was increased, we see, okay, we have 7.6 because of the higher load of the characteristics situation and the defined limit value for the crack width. And so it's very good to see from where comes my required reinforcement. We can see it here in the graphic, and it's also possible to see it in the info text. Good. One topic which is very good and will also improve your daily work in RFEM 6. I will show again the who structure. Is our new development with our intelligent deletion of the results. At the moment, if you want to use it, I will show it. This check must be deactivated, that the deletion of all add-on results by changing the input data will be deleted. This is the behavior which we have in RFEM 5. You change one property or one setting of one object, then all results was deleted. So for example, I go to this column and go to the reinforcement, and I want to use here a surrounding reinforcement, for example, and surrounding here is uniformly surrounding, and say 8 with 14. And I want to have, for example, also cross ties. This is also a new feature which we have now developed, that all reinforcement will be catched by a stirrup or by cross tie, and press OK. Then only the member 4 of this, the results of member 4, member 4 will be deleted. And if I press OK, then all other results are still there. We can check now design ratio by members, and you see the member 4 is now red shown because this design properties was changed, so we have to recalculate it. And by double click on showing the results, only the member 4 will be recalculated, and we have then updated results. So this is one big feature which will save you time, waiting time and calculation time in RFEM 6. So I will go back to my presentation. So this features in the PowerPoint was shown in RFEM directly. If you want to read later all topics, you can download this presentation, and you will then remember very fast all named features which I showed in the presentation. So next feature highlight, special highlights in the beam design is the input of our reinforcement. I showed it before a little bit. The reinforcement is now definable in our main program in RFEM 6. It's not in the add-on like it was in RFEM 5. In add-on you defined it, you had a small window. It was not editable in the main window. It was not usable for other designs. So now we are working in the main table. Then we had a general control of the automatic reinforcement layout. This I will show in a few minutes on a small beam what I want to say with it. RFEM 6 is able to found the needed reinforcement automatically. And what I showed before, to define the stirrups, the cross ties, also to catch each longitudinal reinforcement is a new feature which was not available in RFEM 5. It is necessary, for example, for seismic design, or if you have biaxial shear for columns, then you would need it. Yeah, realistic rendering of the reinforcement in the complete model, in the complete structures is also one main topic which we have. Further, we have some printout templates. This I will show now in the live docu, in the live presentation in RFEM, direct in RFEM. I will use now only a small beam, which is an excerpt from the big structure, to presentate you the things which I want to show. So if I deactivate the results, we see here in the 3D the rendering of our reinforcement, and also the inputs are in the main diagram. If I go into my member here, I make a member set. So I designed the member set. We have everything together in this input. We defined the concrete covers by using the durability. We defined the shear reinforcement. We can use here then more spans, for example. It's very intuitive to go through these 3 input with the bar diameter and the distances. If we don't know what distances we would need, it is possible to use here our auto functions. This is what I wanted to show. You can use the auto function and say, found me a distance between 10 and your limit values, and it should be minimum increment should be 5 centimeters, and then it will be done automatically if you don't know it. Yeah. Also, the longitudinal reinforcement is very intuitive for the inputs. We showed it in some previous webinars how it works, so I don't go now not so much into the details. I only want to show you how the layout function will work on this example. So I will firstly use our results. You see here we have overlapping results of the required reinforcement and the provided reinforcement. So if I deactivate the provided, we see only our required reinforcement, and sometimes it is so that for some designers here is already something that the work ended. They need only the required reinforcement, then okay, then you have here the graph, the values you have, and you can send it to your drawer for the drawings. But if we design here with realistic reinforcement, we can compare it. We have all tools in RFEM 6 which we need. So we see here in over this support, my provided reinforcement is too less, I need more. And to define here more values, I will go inside. So I can select also the rebar normally. Types for reinforcement. I have also to control that I deactivate the reinforcement, but I want to select now the rebars. Yeah? You see now with the selection, if it is activated, I can select this rebars. This was my additional reinforcement. With double click, I will come directly to my rebars now, and I know these are too less. Yeah? And what I will do is to change here the auto functions, that the program should determine automatically the needed reinforcement values which we need. So from 1 to 6, we have here place, and if I press OK, we will see the results are deleted. We have no number there. It must be done by the concrete design, and if I press the calculation, it will be then new designed. And here we have a calculation of the required reinforcement. Then we found the provided reinforcement, and we make the design checks. And here we calculate also the deflection. We see that there are more steps with the effective stiffness method. This I will also show a little bit later. So what we see now is that the provided reinforcement covers the required reinforcement. The program finds six rebars, and we see that it's filled, and the design is then fulfilled. What we can also use here is then for the rendering, for documentation. We have here a very nice window for the 3D rendering. We can rotate and select our view of beams. Then, for example, I will only print my longitudinal reinforcement, make here a template, print the graphic to a template. This will be my longitudinal rebars of members. And then with this setting, I can use this setting for each member in the structure. Each member can be calculated in this way. And if I want to have only the rebars, then you print the stirrups, sorry. Shear reinforcement, and this will be also for members. And then you can, if you make then the multi-print, you can use this template for each member which you have in the structure. Okay. Then for the beams, one topic or top feature for the beam design is that we can use also the netto concrete cross-section area for high reinforced section. So this is also new, that you can remove the concrete area behind the rebars. If you have a very big reinforcement ratio in the cross-section, then you can deactivate in our configurations the area behind the rebars. Very simple, only in the configuration make the check, and then it will be removed. So, and it's also assignable to each member. Then what I want to highlight also for the member design are our results. So first is this diagram, which is very, very good and can be used for the documentation. And then I want to go to our interaction diagrams, which are new. So we have here our interaction diagram. This is a completely new feature which we have now in RFEM 6. It was missing in RFEM 5. So we can select what we want to show, what we want to use. We can then interpret our results. We can see the safety which we have, the moment safety where we are. The blue line is our resistance of the section. Then the green dot is our load, and we see we are nearly on the border. So we should have a design ratio about 1. If you take a look, yeah, okay, it is a 0.96, and we have also the resulting moments, which you can define with the angle of the moments. Then we have the secant stiffness with the moment curvature diagrams and also curvature stiffness diagrams. Everything which you want and need for your work, you can activate, you can send it to the printout report. You have here the table values for your additional calculation when you need some curvatures and so on, or stiffnesses, you can use it from here directly and use it then in other applications, for example. Further, we have the stress-strain diagram in the cross section. We have here the stresses of the concrete. So we have the compression zone shown, and also the stresses in the rebars, in each rebars which is shown. And we can also make in 2D, where we can see on additional drawing how will be the stresses in the cut. This can be also used for some strains. So if we go to the design tables for the variety reinforcement and go to the strains, state of strains. So if we are in the strains and open the diagram, then we have the strains of the section for the provided reinforcement and can also see how is the strain state. We can also go directly from the design check to the results on members, and you can see here and the work here is the safety factor shown, and about the safety factor we can also see the MYD, and this is a moment which was used for calculation of the resistances. And if you want to see the maximum steel stress, you can also see it on the bottom side. And if this is then on the top side, we have a compression. Everything is documented, and you can use it for your documentation in the printout report. Okay, this was then for the main topics for the member design. Then I want to go to the rib design. Here I go back to our main global structure which we had at the beginning at this webinar. And if I deactivate the results, you see here if we have some ribs. The ribs was defined by a member, and this member is then get automatically an eccentricity, and will then integrate the inner forces from the surfaces to the design of this T-section. And we see here that we have different, I will open one rib, and we see in the rib, open it please, we see that if we have the member type rib, then we say the rib is placed on the plus Z side of the surface, and we see that we are able now to have different segments of a member, where we have different widths for the integration of the inner forces and also for the design of the T-section. This is according to the standard, to the Eurocode, for example, where we have here in the field bigger values for the integration width, and over the column and the supports smaller. We can use also this new width according to the Eurocode 2 calculation. It will be calculated according to the length of the segment, which use the formulas from the Eurocode 2. Further topic and nice feature is, we see this is here now shown. If we have reinforced already the surfaces, and we want to design then the rib as a member, then we can directly use the surface reinforcement which was defined for the surface, and this will be then implemented to the cross-section design, and we load and find really the surface reinforcement which was defined and define it here for our design. This is also a new feature in comparison to RFEM 5. In RFEM 5 we had the situation that we have to do it twice. And one thing which is for our members, also new in RFEM 6, we can define the general cross-section geometry for our member. Define the reinforcement in our sections. This is an additional application, and load this section then for the statically analyze to RFEM, and we can then design for moment and normal force this general section directly in the add-on concrete. It is not necessary to export the inner forces and load these inner forces to then cross-section application. It is directly done in our VM. Good. Then I will go to the highlight for the surface design. The surface design have now the possibility to define the reinforcement in our main table in the main window, like it was also for members. So, and this reinforcement is main is an object. So what means it? This means that I can use the manipulation tools, for example, for copy or make a mirror of the defined inputs of our surface reinforcement. And we have also an automatically layered function for the surface reinforcement, like I showed it for our members. I will go back to our structure, activate the reinforcement for surfaces, and to show what I mentioned. For example, if I delete this reinforcement over the column, you can select it, like each object. You select or work with our manipulation tools, rotate, copy, make a mirror, it doesn't matter. Create a copy from where? From this point to the center of this column. And if I copy it, now only one time, then it's here and you can use it again in the assigned surfaces. And you see this reinforcement was defined that it will acting in the slab here and in the slab under the ground floor. Okay. The next feature for what I said before also is that we will have here the automatically layout. How works it? Only show it how it works. So for the automatically layout, you can activate here also the automatism, or for the rebar spacing, if you don't know it, what is necessary, you can say find my necessary spacement automatically, similar like it was done for the members. Okay, then we go to the presentation. Punching shear check is integrated. That's right. This is what I also said. We have the punching shear check directly in the add-on. This means that the surface reinforcement will be automatically taken or used from our inputs. It is not necessary to do it twice because it is everything in one add-on and not in a separate one. In RFEM 5, you have to define the longitudinal reinforcement in the add-on RF Punching Pro separately and again, or additionally is the right word. And what is now also new, we are able to define in RFEM 6 a punching shear reinforcement. So you can define the shear reinforcement for punching, and then we make the design check and the proof for the punching design. So let us go to the next highlight for the deformation analyze. The deformation analyze, as I said in the first slide, is included in the add-on concrete design. And this deformation analyze is based on the effective stiffness method. So in this effective stiffness method is a two-stage calculation So we calculate the first step, the inner forces with linear elastic calculations. Then we calculate on the cross-section area the effective stiffness, if it is cracked or not cracked. And this effective stiffness then will be written to the finite element solver, and we make then the second step an additional analyze for the deformation. This two-step calculation is now new for beams. In RFEM 5 we had here a more simplified solution, which was more on the safety side, but now we have a more accurate solution where we use the stiffness in each element of the beam, and to get then also good and better results. Also a big topic is that we calculate the deformation now over the whole structure. So the members, the reinforced members and the reinforced surfaces are acting together. So it's not so that we calculate now only the deflection for members and only the deflection for surfaces, like it was done or was possible in RFEM 5. So now you have an interaction between the members and the surfaces or slabs. What we can do is also to control the crack formation or crack state for the deformation calculation. This is also new. We can control in our configuration what state of the cracking will be used. So here is the crack state detection. It means the simplest way is to calculate the crack state from the load situation which I analyze. There could be also a situation that the cracks comes from a frequent load situation, for example, because it's acting before the quasi-permanent loads is coming. So in this case, you can analyze the SLS design situations, and then you get an envelope, and from this crack state, you calculate then the deflection, and also you can calculate the deflection on the safety side, always independent of the load, that it will be also always on the crack state, always with the stiffness in the cracked state. What we can do is also to consider some minimum damage factor. In this way, it means if you want to consider some micro cracks, you can use it by a kind of minimum damaging. What is also new, we can show also graphically and in the infotext our damage factor, and this is very, very good and a tool which can help you to understand the results. So if we go to our deformation, we have firstly the calculated deformation in the crack state together with creep and shrinkage. And to understand why it is so, for example, we have now quasi-permanent, and if we want to understand it, we can see here the zeta values. This is a damage factor, and we see that in this area we have cracks, and here we have on the top side cracks, and also in the field. Zeta equal 1 means totally cracked cross section. Here we have nearly and a total cracked. And we can also see then the effective stiffness if we want to see it. We see here where zeta is 0, it's uncracked state. We have the full stiffness. In the crack state, we have then only the smaller stiffness, which is nearly at the cracked state. This possibility is also enable for surfaces. It's also in the same place. You can activate it, and you see then it's for surfaces. I will go to the power slide, to the PowerPoint presentation back, and go to the next point is that we improve the consideration of the creep influence in the effective stiffness method. In RFEM 6, we make now an investigation of the crack state before creep and after creep. It could be the situation that the cracks appears before the creep will be, so in short-term situation, or in long-term state. So therefore, we make now additionally 2 calculations. We calculate the crack state before and after the creep state, so in the analyze state. And what we are developing at the moment, it is now in the development and end test state. So we check the results at the moment and to hope that we can release this in the next weeks. Is that the creep deformation will be only calculated for the quasi-permanent load part of the total load. So only the quasi-permanent load part get then the creep influence and will be then additional considered with the additional short-term deflection from the higher load level. So now we are in the next point for the new design checks in RFEM 6. One very often asked design check in RFEM 5 was the fatigue check. In RFEM 6 we have now implemented it. It is included in the add-on. You can make the fatigue design check according to Eurocode with the simplified design method, or with the method with the damage equivalent stress range. It is possible for surfaces and members, of course, and we see here also the benefit for which we have in RFEM 6. We can compare here now the surface results with a member. This member is a stripe, which is with a width of 1 meter, and we compare here the results for the fatigue design of the maximum steel stress, and we see here it is similar for surfaces and for members. Then what we have also completely new in RFEM 6 is the earthquake design according to the Eurocode 8. So we have here then the ductility check and the capacity design check available. Further then we can design the coupling beams with the diagonal reinforcement for the shear. We have also included now the design of the seismic walls. So we see here, for example, here is a seismic wall together with the building model. It will be then found automatically in one step. And you see here, for example, the design shear wall. It's an envelope for this seismic wall. And one design check which is now new is the beam column joint nodes that we can design it. So we see here was the design of this node from the beam and columns. This is very new. We released it 2 weeks ago. So brand new design check in the add-on. Additional, there are new possibilities or design checks that we can design steel fiber reinforced concrete according to the German guidelines for steel fiber concrete. They are similar like the rules in the upcoming Eurocode 2 generations. Then we can design shear walls, and what is also very new, we can design stripes in slabs. So we can say where are the slabs. If we use the building grid, it will be done automatically. That design stripes will be then generated. It means we integrate then the inner forces from the surface to be able to define the stripe with a cross section as a member. This comes from the United States. The ACI or Canadian standard are working very often with these types, with these design stripes for the design of slabs. So now is this also available in RFEM 6. Let us go to the advanced analysis options, which we have in RFEM 6. The nonlinear material behavior for reinforced concrete. How was it in RFEM 5? In RFEM 5, it was so that you have to activate the additional add-on RF concrete nonlinear. Then you had only the possibility to define or to calculate nonlinear surfaces in the add-on RF concrete surfaces, or you calculate only nonlinear members, columns in the add-on RF concrete members. So how is it now in RFEM 6? In RFEM 6, we have this nonlinear material behavior in the add-on nonlinear material behavior. And this means it's included. So this nonlinear material behavior, this add-on, includes also other material models for steel, for timber, and so on, or masonry. So we have here a full package which you can use. And also then the nonlinear material behavior for reinforced concrete or steel fiber concrete is there included. Further, we have here then the possibility to can totally redefine the stress strain curve for the concrete. Of course, there are some predefined stress strain curves which are necessary for the deflection calculation or for the stability design, but you are able to define your own stress strain diagram. This was not possible in RFEM 5. In RFEM 5, the stress strain curves was generated in the background. This was a kind of black box. It was generated by the properties of the strengths and the Young's modulus and the strains, but the user had no possibility to influence it or define his own stress strain curve. Very good behavior for some load history and load history which we need is that we are now able to consider also the nonlinear plastic behavior of reinforcement bars. In RFEM 6, it is now really possible to have a load history. And the nonlinear calculation is implemented now in the main calculation, in the statically finite element analysis, and also in the main program. It is not in the add-on. In the add-on for surfaces or members. So it's really in the main finite element analysis, and though you are able to interact with other nonlinear materials, for example, for steel, masonry, and so on. And what is also the topic that it is now possible, or if you calculate a structure, you calculate it with beams and surfaces together, not each type of objects alone. You calculate the beams and surfaces in one nonlinear analysis. And here also we can use the multiple core calculations. So this will also increase then the performance if you use the multiple core from your computer. Creep and shrinkage is considered at the time of the analyze, so I can make the analyze from at one edge of the concrete, and then creep and shrinkage is considered to this point. And also one very important topic is that we are now able to switch the material, the nonlinear material, from one design situation to the other one. This means we can define or we can calculate for ultimate limit state with the modified stress strain diagram, which is necessary for it according to the standards, and use then for the deflection calculation according to the serviceability design, the characteristic or the mean values. For example, if we calculate some steel fiber slabs, then it was in RFEM 5 necessary to split it in two files, one for the ultimate limit state, one for the serviceability check. At the moment in RFEM 5, in RFEM 6, it is not necessary. You can do it in one file and switch the stress strain diagram or the material, of course. Yeah, let us stay at the fiber concrete. Now we are also in RFEM 6 possible to calculate a reinforced steel fiber concrete with the statically analyze. So this was not possible in RFEM 5 to calculate a fiber concrete together with some reinforcement in the statically analyze. So how works it with the inputs? I only want, because the time is gone away very fast, I only want to show you the inputs, how it will work. So the nonlinear calculation is activated, as I said, in the nonlinear material behavior. If you activate this, then you have in the material a material model for the concrete. Here we use the anisotropic damage material, and here we have an input tree with some defined stress strain diagrams. You see for SLS we can use it. And what is new from this input, we have generated in the stress strain diagram. You can see it, what diagram is used in the analyze. It's very open, and you can see really the calculation. Further, we have to do it for our reinforcement. We calculate the material model, the nonlinear. It's automatically now bilinear. And if I press OK, then the results will be deleted. And if I want to use now the reinforced concrete, I have to activate the structure modification. I will have to activate also the reinforcements, which I have to consider in the statically analyze. And if you calculate it, you will get then the nonlinear behavior in the statically analyze, the deflection together with the reinforcement and the correct state of the concrete. Okay, so now we have 5, 6, and about 6. This is without creep, and if you want to consider creep, so at about 50 years, we start the calculation new. Then we have also effective or we use then the creep factor in the calculation, and you see we get that the creep factor have an influence that we have bigger deflections. It is increased, and we have here at least the level which we got from our effective stiffness method in the add-on. Okay, let us go back to the power slide and go to the next advanced analyze options, which we would have for the nonlinear material. With the nonlinear material behavior at the moment, it's in RFEM 6 possible also to calculate in the statically analyze reinforced concrete solids with a nonlinear material behavior, of the anisotrope damage material. So this is also possible. And general cross sections from our section can be also calculated non-linear in RFEM. This was not possible in RFEM 5. This is completely new. If you have some special geometry of your beam cross section, you can use also the non-linear calculation because it's totally general developed. The next time advanced analyze is the time-dependent behavior. It's in our add-on time-dependent analyze. We use here the rheological model according to the Kelvin-Vogt approach to consider the creep effects. And what means it? In this case, we can analyze the creep and shrinkage effect successive in time steps. Yeah? We can have some load history step-by-step time steps. We see here also we can see then the results. We have here firstly the load increments, which was increased in 3 steps. And then we have 5 steps for the time for TDA calculation. And we can see also then the increasement of the deformation. We have also very nice calculation diagrams where we can see it. So here we see until here we have load increasement. And from here we have the time steps where we see the creep effect in the deformation will be then, it seems like the creeping curve. And we have here a linear distribution of the time interval. So it means that here the time interval is the same, but the effect of creep is very slow because of the creep curve. And TDA is also possible to work together with our construction stages. The structural construction stages can be then also defined step by step, and you can use then TDA to give them also some time properties and settings. Okay, last point. What we have is then the outlook or view in our developments. The first topic which I want to mention is that we develop at the moment a punching shear check for double heated shear studs according to the IOTA, so according to the technical paper which is necessary in Europe. We have already double heated shear studs for ACI and Canadian standard, so if somebody have a license from RFEM 6 and want to see how we could work, select the design code for ACI, and then you can maybe, if you want, you can see some possibilities. Then on what we are working, this is the static analysis of pre-stressed components, so pre-stressed concrete. We have then, this is possible with the add-on tendons. We can define totally free geometries of tendons inside of a beam or of a surface, and if it is inside, then it is automatically connected. And the pre-stressed for the influence of the pre-stressing forces will be then directly considered in the statically analyze. So it is possible at the moment to put the effect of pre-stressing into the statically analyze for beams and also for surfaces. So here we have the surface for plane surfaces. It is at the moment the condition we are working on the general geometry of surfaces, but at the moment we are able to use it for the plane state. Then one new development which is now also at our end testing process. It's a new member type with the name rebar. This rebar you can use then for totally free geometry, or totally you can define it totally free somewhere inside of a surface, and in future also of a member. It must be inside of the thicknesses, and this rebar is then automatically connected, and you can Then also make some designs of some deep beams like it is here shown. You will get the stresses, the forces in this member. If you work together with the nonlinear material behavior, with the damage elements, then the concrete considered or will be cracked, and the reinforcement will take then all tension strains, and you can also design then your, for example, like it was here, deep beams or some walls. What is possible? We make here some tests. Also, it's more only as information. What is possible? How it works? You had here a beam designed as a surface, and stirrups and the longitudinal reinforcement was used by this definition of the rebar. And here you can see directly the struts, compression struts, which comes from the concrete. It goes from one stirrup end to the other one, and we see here really here how the compression strut goes to the supports here and here, and in the view we see the forces, the tension forces in the stirrups, how this is developed. And here where we have no shear force, we have nearly no force in the rebars. So if we want to analyze something deeper, we can use this new member type rebar in the future for more detailed analyze. So I'm at the end of my presentation. I say thank you for your attention and wish you a nice afternoon. I give the presentation back to Andreas. Goodbye.
Thank you, Alexander, for your presentation. I have an additional hint for you. You can book our online courses. For example, the RFEM 6 course. It's a course for beginners. Then the Eurocode 2 course for the reinforced concrete design with RFEM 6. Eurocode 3 for the steel design. Eurocode 5 for the timber design, and Eurocode 8 for the earthquake design. For more information and prices, just scan the QR codes in the middle, or you can click at the buttons on the bottom of the slides. You can download the slides on the same website where you can find the recording and models, and yeah, you will get an email in the next days with a link to that page. Yeah, and the email contain also your attendee certificate. Okay, that's also all from my side. I thank you for your attention. Thanks to Alexander for your presentation. Thanks to Richard for your help by answering the questions. I wish all a nice rest of the day. Bye-bye.